Thomas Kuhn's The Structure of Scientific Revolutions revolutionized the philosophy of science by introducing the concept of paradigm shifts. Kuhn argued that scientific progress does not follow a linear, cumulative path, but rather occurs through a series of disruptive transformations. In normal science, scientists work within an established paradigm, solving puzzles and expanding knowledge in a way consistent with the paradigm's rules and assumptions. However, anomalies, observations that cannot be explained within the existing framework, accumulate over time, leading to a crisis. When the existing paradigm can no longer accommodate these anomalies, a scientific revolution occurs. This marks a paradigm shift, where the old framework is replaced by a new one that redefines the field's fundamental concepts and methodologies. Kuhn used historical examples, such as the Copernican revolution and Einstein's theory of relativity, to illustrate how new paradigms often render previous scientific perspectives obsolete, not merely extensions of them. Kuhn also emphasized the sociological aspects of science, highlighting that paradigms are upheld by a scientific community with shared norms and values. The transition to a new paradigm is not purely logical or empirical. It involves shifts in perspective and resistance from those entrenched in the old system. Thus, Kuhn challenged the view of science as purely objective, showing it to be influenced by human factors like bias, tradition, and consensus. Importantly, Kuhn argued that different paradigms are incommensurable, meaning they cannot be fully reconciled or compared within the same framework of understanding. This leads to a reinterpretation of scientific truth. Rather than being an absolute, it is contingent upon the paradigm through which reality is interpreted. Ultimately, Kuhn's work reshaped how science is understood, emphasizing the episodic, non-linear nature of progress and the importance of creative disruption. His ideas have influenced disciplines beyond science, including sociology, philosophy, and organizational theory. Life lessons from the structure of scientific revolutions: embrace change as opportunity. Kuhn's concept of paradigm shifts teaches us that progress often requires abandoning old ways of thinking. Resistance to change is natural, but embracing new perspectives can lead to breakthroughs in personal growth, innovation, and understanding. Be open to anomalies and criticism. Just as anomalies challenge existing scientific paradigms, disruptions in our routines or beliefs can be opportunities to question and improve our approaches. Learning to recognize and adapt to inconsistencies is key to growth. Collaboration and community matter. Kuhn highlighted the role of scientific communities in shaping paradigms. Similarly, our personal and professional progress often depends on the shared values, norms, and support of the communities we belong to. Truth is contextual, not absolute. Kuhn's idea of paradigm-dependent truth encourages us to recognize that our perspectives are shaped by the frameworks we operate within. Being aware of this helps us approach different viewpoints with humility and empathy. Revolutions begin with curiosity. Paradigm shifts begin when someone questions the status quo. Cultivating curiosity and a willingness to challenge accepted norms can drive innovation and lead to transformative change in any area of life.